Okay, so I'm Benjamin Moreau. I'm a PhD student and R&D engineer in the University of Nantes and Opendatasoft company. And I will introduce you a tool that we developed in Opendatasoft company and that allows users that have no knowledge of RDF to integrate their data as linked data. So first, let's start with a little bit of context. So we have linked data. So linked data is a set of best practices to publish data on the web. When we publish data as linked data, we use ontologies or vocabularies to describe the meaning of the data. And by doing so, we make our data interoperable, discoverable, reusable, and a lot of other advantages. But despite these advantages, we still have a lot of data that are not stored or that are not integrated as linked data. But it's not a real problem because we have what we call the RDF mapping. And RDF mapping can define the transformation between a non-RDF data and an RDF dataset. So here I have an example of a transformation of a structured dataset into an RDF dataset using an RDF mapping. So an RDF mapping can be seen as an RDF graph, but that contains references to the initial structured dataset. So here, for example, in my node, I have references to columns of my datasets. So I will create two nodes, two types of entities, one that will be identified by values in the name column, and another one that will be identified by values in the birth city column. And these two entities will be linked by the birthplace property. And it will give an RDF dataset with persons that are birthed in a specific place, a specific city. So we can transform non-RDF datasets as RDF datasets. So how do we create an RDF mapping? So we have at least to answer 3 questions. So the first one is what type of resources are contained in my datasets? So for example, cars, person, city, I have to identify each type of resource contained in my dataset. The second question is to find the relation between these concepts. And finally, an important question is to find existing or create new ontologies to describe these concepts. So we see that create an RDF mapping or integrate data as linked data is not an easy task. It requires 2 completely different skills. So the first one is to know the dataset perfectly, to be an expert of the domain. So you have to know the context of the dataset, the meaning of the dataset, the structure of the dataset. So if we take the previous example, it's quite easy because it's a really simple dataset. But when we are translating a dataset from the transportation domain or health domain, for example, it can be more harder. And you have to have a different skill, a completely different skill, that is to be familiar with RDF technologies. So what is, for example, RDFS, what is OWL, and of course, how to use RDF mapping languages. So the problem we are trying to solve with our tool is to simplify as much as possible the integration of existing structured datasets as linked data. And the challenge we are trying to face is to automate part of the integration process that requires to be familiar with RDF. So why we are doing that in Opendatasoft It's because we have a lot of customers that publish data on Opendatasoft platform. And these customers have not always a good knowledge of RDF technologies, but they want to try querying their data as graphs or doing others type of features. So before showing the tools, I will go to the related works. So we already have good RDF mapping languages to transform data as linked data. So we have, for example, Sparkle Generate and RML. So these two RDF mapping language can transform any structured dataset into RDF. So it can be relational databases, JSON, CSV files. And we have another type of RDF mapping language that is YARML. So YARML is a syntax for RML. And our tool will generate RDF mapping into this syntax because at our knowledge, it is the most easy to understand syntax for people that have no knowledge about RDF. But the tool could generate mapping into a Sparkle Generate or RML syntax. And we also have already existing tools that can generate RDF mapping. So for example, we have Karma and RML editor that use a graph representation of the RDF mapping to facilitate the creation of RDF mapping. And we also have Juma that use a block metaphor visualization to simplify the creation of an RDF mapping. So these three tools are really great when we have knowledge of RDF. There are three really great tools, but it's quite difficult to use when we have no knowledge about RDF. So it does not solve our problem. So what we are proposing is a bot that looks like a chatbot and that can integrate data as linked data. So on the right, we have a little demonstration of this bot. So the bot will only ask simple questions about the structured data sets. And when the user answered all questions, the bot generates an RDF mapping and sends the results to the users. The tool is available on GitHub under MIT license, so it's open source. You can check it out and extend it if you want. And we have an online demo. So I will explain a little bit how it works. So we have three main automatical steps in yellow. We have entities recognition step, property recognition process, and a mapping generation step. And between each step, we will ask questions to user to validate or deny some propositions of some steps. So entities recognition, the goal of this process is to identify the type of entities we have in our structured data sets. So to do so, we extract some values in each column, and we search for these values in existing knowledge graph. So for example, DBpedia and Yago, but we could use other knowledge graphs. So when we ask these graphs which resource are these values, we retrieve the type, the class of these resources. So here, for example, for Augustus, Tiberius, and Claudius, we retrieve the class person. Then we send this class to linked open vocabularies. So linked open vocabularies is a search engine for ontologies, for classes and properties. And by doing so, we find the most popular or the most relevant class to describe a person. And we do the same process for each column of our datasets. So for example, for birth city, it will find the DBpedia city class. And sometimes this process is not enough to find a class. So for example, for the birth province, the only city is not found in DBpedia and Yago. So we will not have result for this column. But I will explain later how we can solve this kind of problem. So then we ask question to user to validate or deny each proposition. So we ask if the column name contains entities that are of type persons. Okay, so it validates this concept. And we have the same thing for birth city. So if the person knows its dataset, we assume that it will answer correctly the questions. After we go through a properties recognition step. So the main goal of this process is to find relation between resources and relation between resources and columns of our datasets. So to do so, we extract column names. We can also extract, for example, types of column, data types of column. And we send these column names to linked open vocabularies, again, to find properties. So if we do that for names column, we will get schema names property. We can do the same thing for birth city. We will get birthplace property. And birth province will be also identified as a birthplace property. And then we ask other questions to users. So we ask if name column represents the name attribute of an entity. And we ask another type of question to link the properties to its entity. So we ask which entity, which column contain entities that have a name attribute. So by doing so, we link property to the relevant entities. And when the users have answered all questions, we can go to a mapping generation process. But before serializing the mapping, we can automatically infer new mapping rules by using ontologies. So for example, if I take DBO birthplace properties here, this properties is linked to birth province column, and we didn't found the class that represents entities in the column birth province, but we know that the property of this column is birthplace. So by using RDFS rules, we can infer automatically that birth province will contain entities of type place. It's because the range of DBO birthplace property are entities of class place. So we can also automatically compute RDFS label properties because it's important in the RDF dataset, the resulting RDF dataset, to have human representation of resources. So we can propose RDFS label for each resource in our dataset. We can also saturate the RDF mapping. So we can apply subclass of and equivalence classes rules to find all classes of each resources. So for example, here in DBpedia ontology, we know that a city is also a place and is also a location. So we can add place and location class to describe entities in the column birth city. And again, we can do the same thing for properties. So for example, here we have birthplace property that is also a as location property in DBpedia. And after all this step, we can serialize the mapping, so here, and send it back to the users. So the user can take this mapping and generate an RDF graph, an RDF data, or it can take back this mapping and improve it or correct it if we want to add some mapping rules. So to summarize, I hope I convinced you that it is possible to generate RDF datasets with structured datasets if we have no knowledge about RDF. For the moment, this bot only works for dataset on Opendatasoft platform, but the tool is available on GitHub and it's open source, so it can be extended pretty easily. And we have a lot of other perspectives. For the moment, it's just a beta version of the bot. It's just a prototype. But we want to extend it. For example, we want to use machine learning techniques to learn from user interaction. So to learn from answers from the users. And it will be possible, I think, to reduce the number of questions we have to ask to the users. We want also to identify more classes and properties. Also, we want to add new interactions with the users to improve this aspect of the bot. And we are developing a new user interface to simplify this process. So that's all for me. Thanks for your attention. And if you have any question, I will be glad to answer. If we have some time, I will be able to show a demonstration, a live demonstration, if you want.
Yeah, time
But I can answer questions first.
Okay. So, hello, I'm Imran from Schneider Electric. Thank you for the presentation. It was very interesting. We are targeting today the more structured data, to RDF. Are there any plans that will send structured data like XML as well?
So on Opendatasoft, we have only structured data. So for the moment, we are interested in only structured data, but I think it's possible also to support semi-structured data. I think it's not.
Typically, it's quite challenging.
Yeah.
Like structured data.
Yeah. So with structured data, we have a lot of advantages, like, for example, data types, and it really helps during the transformation, the integration of data as linked data. So yes, with semi-structured data, it will be harder. So, yeah.
Does your tool work if you've got lists inside a column? For example, on pattern, we want to have multiple inventors. We want to have separate them out and bring relationships into the column.
Yeah. So is it work if I have lists inside columns?
Yes.
On Opendatasoft, we have datas are not in columns; they are in a JSON format. So you can have for a key multiple values, like an array, for example, of values. So yes, it works for this.
Relationships within that same field. So if you've got a pattern that will have multiple inventors, you want to say that these people are collaborators.
Oh, okay. Inside the key. For the moment, we are not doing that, but I think it can be supported, yes.
Any others? We've got a few minutes for demo.
Yeah. So this is almost the same examples of during the presentation. So I have a data set, okay, with Roman emperors. I have different fields, different columns, like for example a column with URL to a picture of the Roman emperor. I have birth date, for example, and other stuff. So the chatbot will analyze the data set and will begin to ask some questions. So for example, does the field image in your data set contain a document that contains a visual image? So this sentence, a document that contains a visual image, is extracted from the ontologies. So it's the label of the DBpedia image class. And when the user answers question, he can see the graph visualization of the RDF mapping that is updated in live. So it seems that a birth province column contains entities of type place, so yes. And we can answer question like that. So it found that Roman emperors are entities of type persons. Okay. And then we also sematize properties. And we have the graph that is updated in live. And we can do the same thing for each property. So I will answer rapidly to have the results at the end. And when the user answers all questions, he gets back the saturated RDF mapping, and it can update it on our platform to begin using all features that are relevant and that use RDF. So for example, on the platform, we can execute Sparkle queries. We can filter a catalog of datasets by classes and properties. So for example, you can find all datasets that talk about Roman emperors, about persons, about places. So you can navigate in the catalog with this concept. So I think that's all for me. So, yeah.
Thank you very much.
Thank you.